Good morning. Welcome to our virtual Science 10 class. I am June Emeline Sepulveda, your teacher for the day. Let me check your attendance first. Kindly open your camera and type good morning in the chat box. Have you seen a map before? Is map A similar with map B? What makes it similar? What makes it different? In the previous lesson, you have learned about the different processes that occur along the plate boundary. You have learned that the Earth's crust is divided into major and minor plates, which are moved in various directions. The plates collide, pull apart, or scrape against each other. These are the types of plate boundaries: convergent, divergent, and transform. Since you have learned that the plates are moving, causing geologic activities, what gives an idea for scientists in the past that continents are moving? What is the evidence that will support such claims? This lesson will focus on the most essential learning competency number 5: enumerate line of evidence that support plate movements. At the end of the lesson, you should be able to cite other proofs of continental drift theory, recognize the importance of continental drift theory. Do you know this person? Alfred Lothar Wegener is a German meteorologist. A meteorologist is an individual with specialized education who uses scientific principles to explain, understand, observe, or forecast the Earth's atmospheric phenomena, and or how the atmosphere affects the Earth and life on the planet. He was the first person to formulate a complete statement of the continental drift hypothesis. As a young scientist, Wegener was curious about the Earth's continents. In 1910, Mr. Wegener formed a hypothesis which stated that all continents were once joined together in a giant land mass. He named this land mass Pangea. Pangea, which means entire Earth, the supercontinent that existed 250 million years ago. Continental drift theory states that all continents were once one large landmass that broke apart where the pieces moved slowly to their current locations. Let us unlock some terms that we will be using during the discussion. Drift means to be carried slowly by a current of air or water. Theory is a set of principles on which the practice of an activity is based. Fossils: this is any recognizable evidence of pre-existing life. It can be from million years ago, hundreds to thousands. Fossil correlation is a principle of fossils that states that the strata containing a group of fossils that are all the same age must be of the same age to the fossils. Paleoclimate is a climate prevalent a particular time in geologic past. According to Wegener, the continents are moving. What made Alfred Wegener says that the continents are drifting? What are the other evidence for continental drift theory? Let us try to explore the four evidences gathered by Wegener. Are you ready? Are you ready to play? In this activity, you are going to find clues that will support the continental drift theory. Copy and paste the link in your browser. Don't forget to take a screenshot of your score. You have 5 minutes to do that. Evidence number 1. Apparent fit of the continents. The coastline of the continents appear to fit together like the pieces of puzzle.
Doesn't the east coast of South America fit exactly against the west coast of Africa, as if they had once been joined? This is an idea I'll have to pursue. Wrote by Wegener to his future wife in December 1910. Alfred was trying to get his girlfriend's father to like him. Her father was a well-known geologist.
Did you notice that the western part of Africa and the eastern border of South America seems like a big jigsaw puzzle that fits together? Would fitting edges of continents be enough proof that continents are moving? What are other evidence gathered by Wegener to support his theory? Evidence number 2. Fossil correlation. Identical fossils have been found in the rocks on either side of the ocean. Can you identify the name of this fossil? Mesosaurus is a middle lizard. It is an extinct genus of reptile from the early Permian of southern Africa and South America. Mesosaurus can only survive in shallow fresh water. But a freshwater swimming reptile was found in Africa and South America. Mesosaurus and Lycosaurus are freshwater reptiles. Fossils of these animals were discovered in different continents such as South America and Africa. It is impossible for these reptiles to swim over the vast ocean and move from one continent to another. Fossils were also found in Antarctica. Could it be possible that they existed in this region where temperature was very low? Or could it be possible that long before, Antarctica was not in its current position? Other fossils were found that support the continental drift theory. We have the Cyanometus, Lystrosaurus, and Glossopteris. Fossils are preserved remains or traces of organisms. It can be a plant or animals from the remote past. Fossilized leaves of an extinct plant, Glossopteris, were found in 250 million years old rocks. These fossils were located in the continents of South America, Australia, India, and Antarctica, which are now separated from each other by wide oceans. The large seeds of this plant could not possibly travel a long journey by the wind or survive a rough ride through the ocean waves. For the third evidence, rock and mountain correlation. Identical rocks and mountain structures have been found in either side of the ocean. Fossils and rocks support the continental drift theory. The rocks themselves also provide evidence that continents drifted apart from each other. From the previous activity, you have learned that Africa fits South America. Rock formation in Africa lined up with that of South America as if it was a long mountain range. How come these rock layers in different continents line up together with layers that exactly match? The folded Cape Mountains of South America and Africa line up perfectly as if they were once a long mountain range. Rocks have the same types and age as well. Paleoclimate data. Coal has been found in cold regions, and glacial evidence has been found in warm regions. Paleoclimate data is also known as past climate data. A glacier is a huge mass of ice that moves slowly over land. Glaciers move and leave evidence in a form of scratches, which is called glacial striations. Glacial striations were found in Africa and South America. Bituminous coal. Coal beds were formed from the compaction and decomposition of swamplands that lived million years ago. However, they were discovered in South America, Africa, Indian subcontinent, Southeast Asia, and even in Antarctica. How is a coal bed formation possible in Antarctica if bituminous coal are only found in tropical country? The current location of Antarctica could not sustain substantial amount of life. If there is a substantial quantity of coal in it, thus it only means that Antarctica must have been positioned in a part of the Earth where it once supported large quantities of life. This leads to the idea that Antarctica was once experienced a tropical climate, thus it might have been closer before the equator. These are the four evidences presented by Wegener: apparent fit of the continents, fossil correlation, rock and mountain correlation, and paleoclimate data. Despite Wegener's gathered evidence supporting his idea about the drifting continents, the scientific community rejected him for some problems. He estimated the speed of continental motion, which is about 250 centimeters per year, which is unbelievably high, but he could not explain what force was driving the motion of the continents. Alfred Wegener continued his expedition in the North Pole. He died in search for more evidence in North Pole, and his body still remains there. That ends our discussion for today. Do you have any question? Feel free to ask now. Please answer this question orally. Why did other scientists doubt the idea of Alfred Wegener regarding the continental drift? What is the importance of knowing the continental drift theory? Let's sum up. What is continental drift theory? What are the four evidences that support the continental drift theory? What is the importance of continental drift theory? The phenomena that continental drift theory explains are some of the biggest and most dramatic things in the world: volcanoes, earthquakes, tsunamis, the formation of islands, the distribution of plants and animals around the planet, and so on. These are huge aspects of our lives, and explaining them seems vital, especially in terms of preventing the damage and loss of life from major disasters. Let's evaluate how much you've learned today. Copy the link below and paste it in your browser. You have 10 minutes to finish the task, and go back to this slide after you finish it. Good luck! For your performance test, this is entitled Continental Drift Theory Choice Project. Let's get specific about this topic. Choose one area you want to know about and assume your teacher is going to ask you to present your research to the class. How do you want to communicate your findings? Find a presentation style that best fits you and create something amazing. It can be a song, drawing, dance, and etc. Choose from the following topic: Alfred Wegener, Pangea, fossil evidence, glacial evidence, landforms and rock layers, continental fit. Good luck!